Welcome to day 4 in our sequences unit. Now today is actually going to be a bit of a review day. So our goal for today is to review all of our sequence terminology. So explicit formula, recursive formula, whether it is geometric or arithmetic. And we're going to do this today by filling out a study guide. So if you take a look at the next page in your note packet, you will see that today is a review of sequences. So let's go ahead and fill this out. So let's first talk about, well, what is a sequence? Let's write that down. It is a list of numbers that follows a pattern. All right, a type of sequence that we can have is arithmetic. Now, an arithmetic sequence is formed by adding or subtracting to get to the next term. So arithmetic is formed by adding or subtracting. Now with arithmetic, we also have to remember we have a new vocabulary word called the common difference. Okay, the common difference is the number that you add or subtract. All right, so let's go ahead and let's try an example here. So example, in a sequence, the first term is 4 and the common difference is 3. The fifth term of the sequence is, well, let's go ahead. So we take a look. We have 4 is our first term, and we want the fifth term. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the common difference is 3. So let's first start by subtracting 3. So 4 minus 3 is 1. 1 minus 3 is negative 2. Okay, and then negative 2 minus 3 would then be negative 5. And negative 5 minus 3 would give us negative 8. So I think we have found it. Okay, the other way that you could have also done it is we could have added. So we can go 4. So common difference means you can add or subtract. So let's add it. So 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. So if we take a look over here, it looks like we actually have two different numbers that it could be. It could be negative 8 or it could be 16, whether or not you're adding or subtracting. So we have our two answers there. All right, let's go ahead then. Let's take a look now at geometric sequence. Now, a geometric sequence is a sequence that can be formed by multiplying or dividing. And with that, we have a new vocabulary word called the common ratio. And the common ratio is just the number that you're multiplying or you're dividing. So let's go ahead and take a look at our first example here. In a sequence, the first term is 10 and the common ratio is 2. Find the fourth number. Okay, so let's take a look. So 10 is the first, so that's 1, 2, 3, 4. So let's go ahead. The common ratio is 2. 10 times 2 is 20. 20 times 2 is 40. And 40 times 2 is 80. Now, if I look, 80 is not on my list. So that's not going to be the correct sequence that we want. So let's go ahead and instead of multiplying, let's divide. So 10 divided by 2 is 5. 5 divided by 2 is 2.5. And 2.5 divided by 2 is 1.25. And if I look over here, my answer is D. All right, so we've got arithmetic and geometric. So let's take a look then at a special type of function called explicit formula sequence. So this is a way that we can actually write the sequence. So explicit form, I'm going to go ahead and highlight that, is a formula that allows the number of the term to be entered into the formula to get to the number in the sequence. So let's go ahead and let's try two examples here. So if a sub n equals 2n plus 10, find a sub 6. So we're going to go ahead, a sub 6 equals 2. Now instead of an n, we're going to replace it with a 6 plus 10. So then a sub 6 equals, let's go ahead, 2 times 6 is 12. 12 plus 10 is 22. And we've got our answer. All right, now let's go ahead and let's try another example. So let's go ahead and take a look here. So the third term in an arithmetic sequence is 10, and the fifth term is 26. If the first term is a sub 1, what is the equation for the nth term in this sequence? So we want to know which of these matches the stipulations up above. So I'm going to go ahead and write this as a table of values. So the third term is 10, and the fifth term is 26. We want to find out which of these matches. So I'm going to use my calculator to help me out here. So I'm going to go to y equals, and I'm going to type in the first one. So 8x plus 10. I go to my table of values. Does 3 match with 10? Nope, it doesn't. So it can't be choice 1. So now I'm going to try choice 2. So I'm going to go ahead, 8n, which is x in the calculator, minus 14. And I go to my table of values. Let's take a look. So 3, 10, 5, 26. That is going to match. So that's our answer there. Okay, and finally, our final type of sequence is called the recursive formula. So the recursive formula finds terms in a sequence by using the previous term. Okay, this also is going to have 2 functions inside of the formula. So here we go. If f of 1 equals 3 and f of n equals negative 2 times f of n minus 1, then f of 4 equals. So let's take a look. So here's our first function, and here's our second function. So I'm going to rewrite this as new equals negative 2 times the old function. So let's go ahead and try it out. So f of 1 equals 3. That's our first. So then we have f of 2 equals, now it's going to be negative 2 times the old function. So our old function, we take that and we plug it right in. So negative 2 times 3 is negative 6. Then we go and we have f of 3. So now I go negative 2. I'm going to take my old function and I'm going to plug it in, negative 6. So negative 2 times negative 6 is negative 12. All right, and finally, the one we've been looking for, f of 4. So I'm going to go negative 2. I'm going to take my old function, bring it down, and negative 12. So 2 times negative 12 is 24. So f of 4 equals 24. And that's the recursive formula. So as you can see, we've just reviewed a lot of information. Sequences, the 2 types of sequences, arithmetic and geometric, and then 2 different ways that we can write the sequences in formulas, explicit and recursive. What I'd like you to do now as part of your homework is I'd like you to go ahead and flip to the next page. There are 5 questions that I would like you to try on your own. We're going to go over this at the beginning of class tomorrow. Have a great night, everybody.